Fuel cells are mostly known in connection to hydrogen cars and hydrogen transportations in general. But did you know that there are many different fuel cell technologies out there, thought for multiple and diverse applications? This is not going to be an exhaustive list of all the fuel cells that are out there, but I want to give you an overview of the main types and in which sectors we can expect to find them in the near future. But first, a little bit of a recap of what a fuel cell is. If you know how a battery works, you're halfway there. A fuel cell is very similar. It's a device that produces electrical current from chemical reactions that occur at the two opposite electrodes. But the difference is that in a battery, the chemical compounds are stored inside the battery itself. So we don't need any extra equipment, but once all the chemicals have reacted, the battery is discharged, and we have to either dispose of it or recharge it if it's a rechargeable battery. In a fuel cell, on the other hand, the chemical reactants are stored externally, and then they're pumped through the cell. So as long as we supply this chemical fuel, the fuel cell can produce electricity continuously. And so the energy capacity is not limited by the size of the fuel cell as it is by the size of the battery, but is rather connected to the size of the storage. This is the general working principle, and is valid for all types of fuel cells, but which type of fuel is used, how it is used, what are the conditions for the reactions, and what are the emissions, all those factors vary from fuel cell to fuel cell. A first categorization could be done between low temperature and high temperature technologies. In general terms, low temperature technologies need a quite expensive catalyst to operate. So a catalyst is a material that enables and accelerates the chemical reactions. And in low temperature fuel cells, an example of catalysts, common catalysts are platinum or ruthenium. There are three main types of fuel cells, low temperature fuel cells, that I think it's interesting to mention. The most known probably is the polymer exchange membrane, or PEM. This is the fuel cell we are told will replace our car engines. The PEM is characterized by a polymeric membrane, as the name suggests, that separate the positive electrode from the negative electrode. So they are quite compact and light, and therefore very suitable for transportation applications where the volume and the weight matter. They need to operate with pure hydrogen because they're sensitive to even the tiniest impurity in the fuel. But the good part about it is that the only emission is water. There is another very similar technology that instead operates with methanol. These direct methanol fuel cells are quite convenient because we can skip all the headaches associated with hydrogen storage. But it is still not entirely clear how big of a role methanol will play in the decarbonization, because like hydrogen, methanol has to be produced from other sources, and it's quite of an energy intensive process. So we wait and see how popular these fuel cells will become once we know exactly what it will be the role of methanol. Phosphoric acid fuel cells are the ones who also deserve a place in this top three. Phosphoric acid fuel cells were the first ones to be commercialized, and they are gaining popularity again. They are a little bulkier and heavier than PEM, so they are more suitable for stationary applications. And they operate at a temperature that is around 250 degrees Celsius, which may not seem a low temperature to you, but it means that we can also recover the heat that is produced for space heating or domestic water heating, for example. High temperature fuel cells, though, operate at even higher temperature, above 500 degrees Celsius. And there are two very interesting things about these fuel cells. One is that they can use much cheaper catalysts, for example, nickel. And the second one is that they can use a variety of fuels, not necessarily pure hydrogen. I will link here a video where I talked about steam reforming, so if you don't know what I'm talking about, go check it out. But in these high temperature fuel cells, if we supply sufficient steam together with the fuel, there are the conditions for steam reforming inside the fuel cell, because we have a catalyst and we have the necessary temperature. So methane or other heavier hydrocarbons can be reformed inside the fuel cell, which means that we can use a variety of different fuels. The two main representatives of this category are solid oxide fuel cells and molten carbonate fuel cells. They are both very efficient, competitive with any other energy conversion system that you can think of. And they're mostly suitable for stationary applications because they're quite heavy, and for those applications where constant and reliable power is required. Solid oxide fuel cells are finding their market slowly to residential applications where they can replace our home boilers where we burn natural gas. They can also use natural gas, and they can produce heat and electricity at the same time. The list could go on and on now, but I want to just give you one final example of fuel cell technology that I found quite interesting. That's the microbial fuel cell. Those fuel cells are considered for treatment of wastewater or sewage water. There are specific types of bacteria inside in one of the electrodes, and as the bacteria digest the substances in the wastewater, they cause a redox reaction, reduction, oxidation reactions. So as we eliminate the impurities in the water, we can also collect electrical current. So this was a brief summary. Did you know all these different fuel cell technologies? Which one do you think is the most promising for the future?